10th class students, we have finished periodic classification of elements. Now I am going to start you the chapter metallurgy. See, metallurgy mainly deals with metals, okay, but you should have an idea about non-metals also and how non-metals behaves with metals. So here I'm going to give you videos related to this chapter, principles of metallurgy, or in other terms it is simply referred as metallurgy, and sometimes you can name this chapter as metals and non-metals, okay, because metals individually they do not exist, so always they react with some type of non-metal to form oxides. Now I am going to give you the videos related to it. Do watch them. Here there are two videos which I will be repeating every week, okay, which covers the entire state syllabus of ours, okay, and my explanation will be given to you in the next week, wherein I will be discussing all the question answers including the textbook part. So watch these videos very carefully and make sure that the digital content whatever you receive in physics of chapters, you just save them in your separate pen drive, okay students. So this is what what I want you to do is save those digital videos, so in future you will be needing these videos for quick revision. Thank you.
Hello friends, this video on metal and non-metal part 1 is brought to you by examfear.com. No more fear from exam. What we will study? We will study metals, physical properties of metals, non-metals, physical properties of non-metals, chemical properties of metals, chemical property of non-metals, ionic compounds, extraction of metal from ore. We'll also study refining of metals. So the first question that comes to our mind is, what is a metal? Right? What is a metal? Metals are substances which are electropositive in nature. Electropositive in nature, that means they have tendency to lose electron. That means they have extra electron and they want to lose it. So the generally why it is they have tendency is because in the valence shell they have one extra electron. So we'll study all these things in the maybe in the next two chapters, where we'll explain the structure of the atom of the elements and how it is stable and what is the property of that. So just now you understand that any element which has tendency to lose electron, for example sodium has a tendency to lose one electron and becomes Na plus, because this is more stable. This is more stable and this is not stable, and we'll explain this maybe in the next two chapters why this is more stable. So any element which has tendency to lose electron to become more stable, those elements are called metals, right? All metals except mercury are solid. So generally you take any metal, gold, silver, sodium, potassium, they are all solid except mercury. Mercury is an exception, right? So because the primary definition for us for a element to be metal is that it has tendency to lose electron, and then we observe that all the metals are solid except mercury at room temperature. We are talking about the room temperature actually. Now the question is, why should we study metals? That should come to your mind. Why should we study metals? Why are we doing this? So the various obvious answer is, if you see this, all this ornaments, jewelry, the king crown or your mom's jewelry, everything is generally made using metals. It may be gold, it may be silver, right, copper, but generally these are made of metals. The hammer which we use in our house, this also is a metal part. Why? Because it has more density. We'll learn the physical property of metal, but now you can understand that the hammer, this part is also metal. The nails which you use, it has a critical role. You make furniture, nails are required. Nails are very much required. So that is also made of metal. The wires which are used for fencing is also made of metals. The guns which you see in movies, the police people use the guns to protect ourselves, they are also made of metals. Most of the electrical appliances, if you see, are made of metals. The body of the fridge and a lot of entry paths are also made of metals. If you see the wire which conduct electricity, which transmit electricity from some power station to our house, these things are also made of metals, because metal is a good conductor of electricity. We'll learn that. The trophies and all, normally, they are made of metals. The car, any automobile, maybe bike, the bike you ride, the cycle, all these has metal involved, because they need strength and those kind of stuff. So they all need metal. If you see, most of the car, the body is made of metal. The watch we use, right, that is also has metal. Sometimes it has a metal case. Even if you take a plastic watch, it has some element inside it which is metallic. So metal are used in a lot of places. So if you see in our day-to-day life, we do use metals. And if you talk about your jewelry, if you talk about the car we use, the bike you use, the electronic appliance we use, the electricity we have, the furnitures, a lot of places we use metals. And that's a good reason why we should study metals, because if we are using metals, we should know metals, right? So let's understand a brief history of metals. You will surprise to know a lot of stuff. The first metal that was discovered was gold, and that was very, very old in BC, almost 6000 BC. And that is because gold is non-reactive and it exists in the free form. And there was a craze for gold. It was costly also. And there used to be a group of people called alchemists. They used to believe that they will find something called philosopher's stone, which can convert everything to gold. And there were a lot of studies done on that, but nothing happened. And after that, they found something similar to gold, looks like gold, that is copper. And then silver, because these are generally inert, you can say metal, they don't react much. And then they found lead, then tin, iron was used in this age, and this is what we call Iron Age, right? Iron Age. And then mercury was found. All these metals were found in the BCs. If you see the platinum, antimony, bismuth, zinc, arsenic. And then after that, all these metals were found. If you see, aluminium was found in 1827, very recently. So if you see, it took so long to find these metals, but these were found just because they're less reactive. And then they found all these metals. If you see, silicon was found in 1823 only, and this has critical. You can't say silicon is a metal. Silicon is neither a metal nor a non-metal. It has a lot of debate goes on. Some people say it's a metalloid. So anyway, so what I'm trying to say is that it took time. It took time to find metals. Only if you see 6000 or maybe 6000 before BC, the only metal known was gold, and then they come to know about copper, and then they came to know about something called iron, 1500 BC. They called Iron Age, right? And then they came to about zinc, and then titanium, and then if you see boron, calcium, magnesium, all were recently found, and aluminium was also recently found. So that's how they found the metal. It's not that one day they found everything. It's our ancestors who did research, and based on their experiments, they found all these metals. Some of the common metals which we use is gold, which is silver, copper is this kind of color, zinc, then you have aluminium, you must have seen aluminium in your home, iron, little blackish, then you have sodium, then you have magnesium, then you have potassium, you have calcium, then you have cobalt, and then nickel. So these are the common metals that are used. I just took the slide just to make you familiar with the look and feel of the metals. Gold looks like this, a very different look. Copper is this, the silver is this. These things we are generally aware, but these metals are something we should not much aware. So it's better to have a look and feel of this. This is sodium, right? And if you see, this is the look and feel of most of the metals. So it's better that we just have a look at least once, so that we can visualize the metals. When I talk about sodium, you can visualize the sodium looks like this. When I talk about magnesium, you can visualize the magnesium looks like this. When you talk about nickel, you can visualize something like this, right? Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again. Hello friends, this video on metal and non-metal part 2 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1. So now, having told the reason why we are studying metals, the history of metals, let's understand the physical properties of metals. So metals has some physical property. If you see all the metals which we have seen just now in the previous slide, they shine. Everything has shine. So you can say that metal in the pure state has a shining surface. And please note this physical property is not applicable to all. Maybe there will be exceptions, because the main definition for metal is anything which lose electron, right? So that is the main definition. So we don't define metal based on the physical properties, but on the chemical property. And the chemical property is that anything that lose electron. But when we have defined the metals, we observe that most of the metals, I'll say most of the metals have shining surface. So this property is called metallic luster. So if somebody asks you what is metallic luster, you can say that metals in the pure state, most of the metals in the pure state have a shiny surface. If you see the gold, it shines. If you see silver, it shines. Right? Copper shines. So most of the metals has a shiny surface, right? And this property of the metal is called metallic luster. Hope you understand this. Most of the metals have shiny surface, and this property is called metallic luster. And please note, most of the metals I'm telling. So to do activity on this, because I just told you, you just want to prove yourself, right? So this is curtain on. You can take some sample of iron, copper, aluminum and magnesium from your lab and look exactly like this, right? And just note the appearance of this. You'll observe that they are shiny. So what you can do, if the lab assistant has not given you a clean one, what you can do is you can clean that metals by rubbing them with sandpaper. You know sandpaper, paper which has sand stick to it, so you can clean stuff with that. So you can clean that and you see it glows actually, you know, it has a shine, and thus we can say that metals has shining surface. If you talk about the hardness, you will see that most of the metals are hard. I'm telling most of the metals. For example, sodium is not hard, you can cut with knife. But most of the metals you can't cut with knife. You take gold, you won't be able to cut with knife. You take silver, you take iron, you take copper, it is difficult to cut with knife. So that's why I say that metals are generally hard. That means most of the metals are hard. It's not the rule that metals has to be hard, but most of the metals are hard, right? And the hardness varies from metal to metal. For activity, what we can do is we can take again iron, copper, aluminum and manganese, right? And try to cut these with a sharp knife, and you'll observe that you'll not be able to cut these. And that's why we can say that metals are hard, right? You can do this in your lab. You get these metals, small piece in the lab assistant, and then try to cut them with a knife. You'll observe that you'll not be able to cut those things, right? Now, you take sodium. Sodium is also a metal. And now, we have to be cautious because sodium is very reactive. The moment you take out, we burn also. Then you have to hold that with the pair of tongs and then try to cut it. And you see that you are able to cut sodium. It doesn't mean that it's not a metal. It is still a metal, because the reason, the definition of the metal was anything that lose electron is metal, and sodium very well lose electron. So in that case, sodium is a metal, but this physical property doesn't match. So most of the metals are hard, but sodium is not hard. So as I told, the physical property is not for all the metals. Some metals follow. In fact, you can see that 95% of the metals follow that, and maybe 5% doesn't follow that. So maybe we can, since 95% follow, so we can still create a general rule saying that most of the metals are hard, most of the metals have shining luster, right? Now, malleability. Malleability is something which can be beaten into thin sheets, right? So, for example, if you see that you have this metal, you take the hammer, beat it, you can get something like this. The aluminum foil, if you see, and this container you must have used or you have seen in the hotels, when you take parcel, they generally put the stuff in this kind of container. They're all aluminum. So here if you see, it is very very thin, right? If you see, very very thin, very very thin. So the property of any metal to be beaten into thin sheet is called malleability. Please note, malleability is nothing but if you can beat a metal, this metal, let's suppose, into thin sheets, that property of that metal is called malleability. So most of the metals are malleable. Obviously, exception sodium, you can't put and make a thin sheet of that. But normally, if you take iron, also if you take aluminium, gold, they're all malleable, right? You can take hammer and you just hammer, and then you'll find that it will be a thin sheet. For this also, if you see that gold and silver are the most malleable metals. Gold and silver, they are most malleable metals. But they are not used for aluminum foils. Why? Obviously because it's very costly. So you can't afford a aluminum foil to wrap your food and throw it because it's very costly. So generally we use aluminum because it's a little cheaper, right? So for this, the activity is you can again take iron, zinc, lead, and copper, and then you place one metal and just hammer it. You observe that the thickness will decrease, right? For example, this is this much thickness. After hammering, it may become this much and expand in area. That means you see that you are decreasing the thickness, and if you keep hammering it, you may observe that you may get a thin sheet like this. And that's what, if you see that, it means that it is a malleable substance, right? Similarly, ductility is nothing but you have the ability to draw the metal into thin wires. Thin wires. For example, you have this metal and you convert into small thin wires. Then it's called ductility. Please note, malleability and ductility are different. Malleability means you have to convert that into thin sheets, and ductility is nothing but you have to convert them into thin wires. Both are different. Gold is the most ductile metal, and you know that you can make 2 kilometer length of gold from 1 gram of gold. 1 gram gold is such a small amount. Even from that, you can make 2 kilometer length of gold. It's such a ductile element, but still we don't use that to create generally the wires because it's very costly. So we use copper, right? So similarly, the next physical property is good conductor of heat. Most of the metals here also I'm telling most of the metals are good conductor of heat. And if you see these aluminum utensils in the home or steel utensils, I won't use steel now because steel is not a pure metal. Anyway, aluminum utensils, if you see, or copper utensils, if you see, why it is used? Because they are good conductor of heat. So if you use some burner in this gas stove, it should conduct heat, and that's why. And then only the food here will boil or cook, right? So metals are generally good conductor of heat. Good conductor of heat means it will conduct heat. They have a high melting point, and that's the reason if you see the same picture, that's why it is used generally for the utensils, because they won't melt so easily, right? If it has low melting point, for example, if you take paper, the moment you put it in fire it burns, or in plastic, right? It's a low melting point. The moment you put it inside near fire it melts. Those kind of stuffs can't be used for making utensils, right? Generally, high melting point stuffs are used to make utensils because it can resist heat. Because when you are cooking, it gets the heat. So if it is having low melting point, it may melt. So generally, metals are used because metals has high melting and boiling point. Tungsten has the highest melting point, whereas silver has the lowest boiling point. So this is something to remember. There is no concept in this. It's all based on observation. They have found that tungsten had this highest melting point and silver has the lowest melting point. For this, somebody would have done the experiment in the lab. They would have taken all the metals, find the boiling point, and they found that tungsten has the highest boiling point, melting point, and they found that silver has the lowest boiling point. Sodium and potassium has very low melting point. So sodium and potassium are metal, but generally it doesn't follow the physical property of the metal. It doesn't it's not hard, right? It is not malleable, not ductile. So in that case you can see that. But anyway, sodium and potassium has low melting point. They are all the exception here. Good conductor of electricity. If you see, most of the wires, the wire which we use in home, they are all made of copper. Most of them, right? Because copper is a good conductor of electricity. So similarly, metals are generally good conductor of electron. So most of the metals are good conductor. Most of the metals are good conductor of electricity. Similarly, sonoricity, if you see the bells in the temples, right? So the moment you hit it, it makes noise. So that property is called sonoricity. It should make noise. If you take iron, if you hit the hammer, it will make noise, right? So if you have a coin, you drop it, make noise. Why? Because it's sonorous. And most of the metals are sonorous. High density. Metals have generally high density. They're heavy. They have heavy weight. And that's the reason if you see the weights which you use, or the hammers, right? The hammers, if you see, is use of made of metals. Also the weights which you use in the shops, you must have gone, right? They use a weight. For example, this is 1 kg weight. 1 kg weight, 2 kg weight. All the weighing weights they use in the shops, you must have gone in grocery shop, right? Something like this, it says 1 kg. And they'll use it to weigh. Why they use it? Because they are all metals and they are heavy. So with a small size, you get 1 kg. So that's why they use the metals in that case. So the point I'm trying to say is metals have high density. And here iridium and osmium has the highest density, whereas lithium has the lowest density. Please note, lithium has the lowest density and iridium and osmium has the highest density. So generally metal has high density. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again. Hello friends. This video on metal and non-metal part 3 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 and part 2. Once we're done with metals, we know what is physical property of metals, what metals looks like, the chemical property of metals we'll study later. Now let's study what is non-metal. Non-metal is just reverse of metal. So they have tendency to gain electron. So metals has tendency to lose electron and this guy want to gain electron. Correct. So metals want to lose and this guy want to gain electron. So this is my electron and this guy want to gain electron. And please note there are only few non-metals. If you see the periodic table, maybe in the next 2 chapters, most of the elements are metals. There are only few non-metals. I can say that carbon, nitrogen, oxygen, fluorine, and all the noble gases, right? So there are few non-metals as compared to metals. For example, carbon, sulfur, iron, oxygen, hydrogen, etc. But if you see, 50% of the earth is oxygen only. One particular non-metal itself is 50% of the earth. If you see, hydrogen and oxygen are the major constituents of ocean. So non-metals are less in numbers, but they are more in quantity. Most of the things around us is non-metal, right? But the number of non-metals are less. The metals, there are a lot of non-metals. For example, sodium, potassium, calcium, magnesium, iron, copper, zinc. But there are limited number of non-metals. But the quantity is more. 50% of the earth is oxygen. If you see ocean, they are all hydrogen and oxygen because they are all water, right? So, and non-metals are generally solids or gases. If you see hydrogen is gas or solid, for example carbon, except bromine, which is liquid. So non-metals are all solid, liquid, gas, but most of them are solid and gases except bromine, which is a liquid. Again, this is something we should learn, nothing to explain in that. This is all found by observation. Now the next question that comes to our mind is why should we study non-metals, right? So the first thing, if you see the tree takes CO2, carbon dioxide, correct? And then it releases oxygen, correct? Carbon dioxide is essential for survival of tree. Oxygen is survival for our existence, human existence, right? So if you see, it's very critical. It's a very critical thing. If there is no carbon dioxide, no trees. If there is no oxygen, we are not there. So they are very, very critical, right? If you see the oxygen which you get here, we take it. It's very, very critical for our existence. Without non-metals, we will not even exist. The rocket, if you see the rocket which we use for scientific purpose, the combustion happens. It happens because of oxygen. Even if you see any car and all, any car, anything, car or bike or aeroplane, each of these needs oxygen to burn, because if there is no oxygen, it won't burn. If the fuel won't burn, it won't work. So the basic principle behind all these moving things are combustion, right? You take rocket, you take aeroplane, you take bike, you take car. All these work because of oxygen. If there is no oxygen, this won't work. So if you take your car in some planet which doesn't have oxygen, it won't work because the fuel won't burn. If you see the coal has a huge implementation. Coal is a non-metal, right? So, for example, in thermal power plant, it is used to generate electricity. Thermal power plant. It is used for cooking in rural areas, right? So, coal has a huge implementation. Coal is also used to create cement or something. There, it is used in raw material for a lot of factories. So, coal has a huge implementation, and that's a non-metal. So, if you see the diamond, the ladies' best friends, they are also non-metals. The carbon. Diamond is nothing but carbon. The graphite, which is used for electrode in most of the batteries, if you open any battery, that 1.5 volt battery which you get in the market, it has a graphite. And graphite is nothing but non-metal. The neon lights which you see, neon is non-metal. The helium is used in this air what do you say, air balloon. So this is also non-metal. Sometimes hydrogen is also used, and that's also non-metal. In the swimming pool, they used iodine. Iodine for disinfection. That is also non-metal. Sorry, they use chlorine in this case. Yeah, they use chlorine. They use chlorine for disinfection of the swimming pool, right? So that is also non-metal. The chips has silicon in that. I won't say silicon is a non-metal, but some people say silicon is a metal, some people say it's non-metal. Actually, some people say it's the metalloid, where it's neither metal nor a non-metal. So anyway, I just put this. So silicon is used in all the chips, the microprocessors you see, all the chips are silicon because all the transistors are made from silicons. The fertilizers, they use non-metals, ammonia and all. The antiseptics, they use non-metals, iodine. Yeah, iodine is used in antiseptics. So if you see, non-metal has a variety of uses. You take the first thing is our home system, the existence of plants and trees, our existence, and then you use anything. The generator, the car, the bike, where the combustion happens, right? We use petrol to generate power. That is also we use non-metals. The coal for electricity, cooking, diamonds for ornaments, the helium gas, chlorine, iodine, fertilizers. Non-metals has a lot of application. Before we go into the physical property of non-metals, let's have a brief history of non-metals. Metals, if you see, were found in 6000 BC. It was found way early, but non-metals are not like that. So if you see, carbon is the only metal which was found in the prehistoric time, and that too in the form of coal, right? And if you see, after that, it's all 13th century, right? There is no non-metal which was found in BCs. The only one was the carbon, and then phosphorus was found in 1300 century, and that it was used to make explosives. And after that, the next metal that was found or given name was oxygen. And please note, if you see, oxygen name itself was coined in 1774, not very old. Oxygen is 50% of the earth, right? But the name was not given. Why? It is not visible. It is not visible. Nobody knew it exists, right? But if you see gold, silver, it was all visible. So it existed. People could just pick it up and say, okay, no, it looks like gold. It's orange color. It looks like silver. It's a silver color. But these things, it's invisible, right? Most of them are invisible in the gas form. So it took more time to find these non-metals. If you see, oxygen was found in 1774 itself, and the name was given by Lavoisier. Similarly, nitrogen itself was found the same year by Lavoisier. He did all the experiments and found that nitrogen is a gas, and he gave this name. Chlorine was also found in the same year by Scheele. Sulfur is again another non-metal which is found by Lavoisier in 1777. Hydrogen, if you see, I tell that no, most of the ocean is hydrogen, but still nobody found it, that there's a gas called hydrogen, because all invisible. In 1783, this guy again, Lavoisier, found this guy, hydrogen. So with this, the point I'm trying to drive is all these metals, non-metals were found very recently, not very old, not even 250 years old. And that's the beauty. This thing existed, but nobody found it, right? So let's start with some physical properties of non-metal. First thing is it doesn't shine. If you take coal, it won't shine, right? There's no shine in that. They are not sonorous. Again, you take the same example, coal. I see coal is the most available non-metal which you can touch, you can feel, right? So if you take coal also, it won't make noise the way a coin makes, right? They're not malleable also. You can't make a coal thin sheet. They're not ductile also. You can't make a wire from the coal, right? They are very poor conductor of heat. You can't connect heat from that. They are very poor conductor of electricity. If you want, you can take the setup. What you can do is you can take this coal like this, right? The battery somewhere here, and then put some bulb, something, right? You add this and you cross a coal from this, and you will find that the bulb won't glow because the coal won't connect electricity. You can do this. And they are generally soft. You see, the coal is not very hard. If you hit with the hammer, it breaks, right? It's not very hard. It's generally soft, right? They have low density. If you see the weight of the coal, if you take, let's suppose, this much big coal, and you weigh this, and if you take this much big iron, you weigh this guy, iron will be much more big than coal, because density is less. If you see, it's all porous kind of substance, right? Generally the non-metals, they are very low density substance. Although, as I explained, the properties of metals and non-metals, the physical properties, they are exceptions. As I told, because the metals and non-metals name is defined by this property of tendency to lose electron and gain electron, right? And then they found that, okay, they have some physical property, but they have some exceptions also. For example, I told that all the metals are solid, but mercury is the exception. Mercury is liquid. Mercury is a liquid, exception. As I told that metals have high melting point, but gallium and cesium has low melting point. I told that generally iodine, non-metals are non-lustrous, but if you see, iodine is a non-metal, but it has shine. As I told that metal is a non-conductor of electricity, but if you see in non-metal chapter, I told graphite. Graphite is a conductor of electricity. Graphite is a non-metal. So if you see, graphite is nothing but a form of carbon. Graphite is an allotrope of carbon. Diamond is again allotrope of carbon. So there are so many allotropes of carbon. So we're studying a new chapter on carbon actually. In the next chapter will be a different study on carbon also. What are the allotropes? What are allotropes? Allotropes are nothing but you have elements which have different properties, right? So they are same. They are all carbon, for example, in this case. So if you see, property of some chemical exists in two or more different forms. So they are all carbon. If you see graphite, diamond, coal, right? All are carbon, if you see, but all has different properties. This guy shines, this guy is very hard, this guy is good conductor of electricity, this guy is bad conductor of electricity. So all are allotropes of carbon. Allotropes are nothing but different structural modification of elements. So the way the carbon is structure is different. But if you see, all has carbon element. If you go to the atomic level, all these three are combined of carbon. But the way it is structured is different. And that's why it has different chemical properties, right? So the atoms of these elements are bonded in different manners. So we'll learn more about carbon bonding and carbon allotropes in the next chapter. But for now, you just understand that is the exception, that carbon, they are carbon allotropes. In fact, graphite, you can see graphite is a carbon. And also if you see diamond is also carbon, and this is the hardest metal known. I mean hardest substance known, it's not a metal, hardest substance. And we say that metals, non-metals are soft. But if you see, diamond is the hardest substance known and is a non-metal. Also if you see, there's the exception that sodium, potassium and lithium, they are metals, but they are so soft that they can be cut with a knife, and they have low density and they have low melting. So they don't follow the physical property of. I have used this word metalloid. What is metalloid? is nothing but elements which are neither metals nor non-metals. So they don't exhibit the property of metals and non-metals. Again, there's still debate going on which all are metalloids, which all are metals. So generally, the 6 elements are commonly recognized. I'll say commonly not recognized. There is no concrete recognition on this. Commonly, boron, silicon, germanium, arsenic, antimony, and tellurium are called metalloids. Again, there's still debate on that. So because they are, some people will say silicon is a metal, some will say it's a non-metal. But generally, yeah, the 90% of the people, they are on the agreement that these are metalloids because they have properties which are between metals and non-metals. They have the exhibit property, mixture of metals and non-metals, and they are difficult to classify actually as metal and non-metal. Now is the question time. Give the example of metal which is liquid at room temperature. This we know, it's a very simple answer. The answer is mercury. Mercury is liquid at room temperature. Give the example of metal that can be cut easily with knife. You know, it's sodium. We can cut with knife. In fact, potassium also we can cut with knife. Which is the best conductor of heat? We have told that silver is the best conductor of heat, and which is a poor conductor of heat. We have told that there is an exception, and that is mercury and lead. They are poor conductor of heat. There is an exception to that. Generally, most of the metals are good conductor of heat, but mercury and lead are exception to that, and they are poor conductor of heat. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.